Okay guys, so we're going to start here 7.3, talking about this idea of what is a reference angle. And there we go. Okay, so a reference angle is an angle who measures between 0 and 90 or 0 and pi over 2. Don't worry about these symbols, it's just beta. It just looks like a fancy B, okay? So it's basically has to be a positive value, right? It's always going to be positive. Always name a reference angle in the same units as the given angle. So if I'm in degrees, I would name it in degrees. If I'm in radians, I would name it in radians. Okay, makes sense. So stay in the same units. A reference angle measures how far an angle terminates from the x-axis. So you're going to look at the terminating side and how far is it from the x-axis. So for example, 60 degrees. If I look at 60 degrees, I'm looking at how far is it from the x-axis, right? So here, for example, I would just graph 60 degrees, right? So wherever my 60 degrees is. Well, how far is it from this x-axis, from the positive x-axis in this case? It's just 60 degrees away. So my reference angle is just 60. 3 pi over 4 is quadrant 2. So here's an example of a quadrant 2 one. So in 3 pi over 4, right, which is over here, okay, 135 degrees. My question is not how far is it from the original x-axis, but the reference angle wants to know how far is it from now the closest x-axis. How far does this terminate from this x-axis? This is the reference angle that I want. Well, if this is 3 pi over 4, or 135 degrees, then we know that away from here is another 45 degrees, because this is exactly in the half. So this would be another 45 degrees. But since they gave it to us in radians, we have to rewrite that in radians as pi over 4. Okay, let's do the same thing for the next one. So we're at 250. So where would 250 be? So we would go ahead and graph it. Right, 250 would be down here. Okay, but again, I don't want how far it is from the beginning. That's 250. What I want to know is just how far away it is here from the x-axis. So it's from that closest x-axis, either the positive x-axis or the negative. In this case, the negative. So this is 250. This is 180. So I'm just going to do a simple subtraction problem. How far is 250 from 180? And my answer is 70 degrees. So the reference angle is 70 degrees. Again, it's how far away is it from the x-axis. All right, 7 pi over 5. Now that's not one of the ones we know, so you could use your conversion factor, multiply by 180 over pi, and simplify it, or you could have a calculator maybe on this one. We get that this is about 252 degrees. So just to get an idea visually where that is, all right, that's pretty similar to the last one. So again, I want to take that 7 pi over 5. This is, again, I'm going to stick to radians here. This is pi radians. So I want to do the same subtraction problem I did before, but I'm going to do 7 pi over 5 minus this, because I only want this distance here, minus pi. So when I get a common denominator, that would become 5 pi over 5. 7 pi minus 5 pi would just be 2 pi over 5. So my reference angle is 2 pi over 5. 342. Which quadrant am I in? So for this one, when I'm in quadrant 4, 342, I want to figure out this distance. Again, how far is it away from the closest x-axis? So what would that be? Well, it would be my entire thing, which is 360, minus the 342 to figure out that difference. And so I would just subtract and get 18 degrees as my reference angle. 11 pi over 12, well, that's just a little bit short of pi. And so again, the reference angle, though, is this missing part. So I would subtract, in this case, pi minus 11 pi over 12. Common denominator would give me pi over 12. Okay, so again, reference angle is just how far is it from the closest x-axis. If we're in quadrant 1, it's just the value of the angle. Quadrant 2, you've got to see how far it is away from pi or 180. Quadrant 3, same thing, how far is it from pi or 180. In quadrant 4, how far is it away from 2 pi, or 360, right? Okay, let's just review our special right triangles for the next part. So here we go. You guys remember your 30, 60, 90s and 45, 45, 90s? Let's start with the 45, 45, 90s. If this leg is x, the other leg is x, and then our hypotenuse is x times root 2. Hopefully you remember those, okay? For the 30, 60, 90, this is the one that's a little harder. So our short leg across from 30 is x, which means the long leg across from 60 is x root 3, and the hypotenuse is always 2 times x, or double that hypotenuse. All right, so what happens if our radius is 1? Now, why would I care about a radius being 1? Because we're talking about unit circles, right? And we talked yesterday, the unit circle has a radius of 1. So if I have a radius of 1, that's equal to the hypotenuse here, which is 2x. So I would set up 1 equals 2x, solve this for x, and so my short side, x, is just going to be 1/2. Okay? For the next part, x root 3, well, if my x was 1/2, then therefore my x root 3 is just 1/2 times root 3, and that just simplifies to root 3 over 2. So I have one leg of 1/2, one of root 3 over 2. For the 45, 45, 90, let's do the same thing. If my hypotenuse is 1, I set x root 2 equal to 1, divide by root 2, and yes, you have to rationalize, and I get root 2 over 2. And that works for both of my legs since they are both equal to x. And those are my values, okay? So basically what we're going to do now is we're going to take these little triangles and we're going to place them on the unit circle to see what the coordinates are for my 30-degree angle, my 45-degree angle, and my 60-degree angles. So let's look at the next page. Okay, ordered pairs by special angles. So what we're going to do is just kind of work through here, and we're going to flip back and forth a little. We're going to talk about this first one with 45, 45s, then we're going to talk about 30, then we're going to talk about 60, and we're going to flip back to the other page to do the examples as we go here. All right, so let's start with 45s. Draw the ray in each quadrant that is 45 degrees from the x-axis. So it's just here, 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 and here. Okay? In the first quadrant, draw a dotted line from the point of intersection, here's my point of intersection, on the unit circle to the x-axis to form a right triangle. Dot, 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 right triangle. Good? Use your understanding of right triangles to determine the values of x and y for each point of intersection, and write in the coordinates of each point. Okay, so this is my x, this is my y. Okay, so my coordinates here are x comma y. But we know this is 45 degrees. So we know this is 45 degrees. The hypotenuse is 1. It's a 45, 45, 90 triangle with a hypotenuse of 1. Well, we just did that on the page before. We had a 45, 45, 90 triangle, hypotenuse of 1. So both of the legs are root 2 over 2. It's going to be exactly the same. And so my coordinates here are going to be root 2 over 2 and root 2 over 2. Always, always, always. So now for the other ones, it's just a reflection. It's going to be the exact same triangle. It's going to be the exact same coordinates. Everything's going to be the same, except for my signs are going to be different. So if I am in quadrant 2, right, my x is going to be negative root 2 over 2, but y will still be positive. Down here in quadrant 3, my x is negative and my y is negative, but it's the same numbers. And down here, the x is positive and y is negative. And again, for my angles, let's just write those on there so we know. This is 45 degrees, 135, 225, and 315. And then we can also write them in radians so we know pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So nice and easy, and you do have to memorize these. For the 45s, all of the 45 multiples of 45s, you're always going to be at root 2 over 2, root 2 over 2. So this is your sine, this is your sine, this is your cosine, right? You could figure out tangent, cotangent, you can figure everything out. And then for the other ones, it's just with positives and negatives that switch. All right, so now let's go to example 1 on the next page, and then we'll come back and do the others. So example 1, evaluate each of the following now. So it says the sine of 45. Okay, so how do I evaluate the sine of 45? So let's see. Well, sine is just going to be the y value. So let's write that up there, right? And again, you can kind of flip back and forth if you need to. So if I want the sine of 45 degrees. Well, let's go back. Here's 45 degrees. This is x, this is y, so this is sine, this is cosine. So my sine of 45 degrees is just going to be this value right here, root 2 over 2. Okay, let's try another one. B, cosine of 135. Okay, well, I go to 135. Here it is. Again, this first one is cosine. This is sine. So cosine is negative root 2 over 2. So my answer is just negative root 2 over 2. Tangent of 225. Well, tangent we know is y over x. 225 is in quadrant 3, so they're both negative. So I would have negative root 2 over 2 divided by negative root 2 over 2. And then I've got this complex fraction that I got to simplify. Well, what does that just become? You guys know. Negatives cancel out. This is the same thing, so my answer is 1. Cosine of 315 in a similar fashion. Go back to your picture. See 315. 315 is here. Okay? Cosine, we were asking for cosine, right? Cosine, sine. Cosine's my x value. It's just root 2 over 2. Okay? Tangent of pi over 4. Tangent, here's pi over 4. Sine over cosine, well, that's just the same thing over itself. So guess what? Tangent again, just going to be 1. Okay? Sine of 5 pi over 4. Sine, 5 pi over 4. Here's 5 pi over 4. There it is. All right? Sine, oh, this is cosine. This is sine. Negative root 2 over 2. Now, as you get better at these, you're not going to have to keep looking at the picture every time. But for now, it helps us to refer to it. Cosine of 3 pi over 4. Oh, that's the same as this one. Negative root 2 over 2, right? 3 pi over 4 and 135 are the same, okay? Tangent of 7 pi over 4. Well, have you noticed anything about the tangents here? They're all 1, 1, right? So they're probably going to be either 1 or maybe negative 1. So let's take a look. 7 pi over 4. Here's 7 pi over 4. Oh, yeah, if I do y over x, I'm going to get negative over a positive. So I am going to get negative 1 in that case. Okay, I'm going to pause this first video. Oh, let's figure out this part. So the signs, what do you notice about all the ones that asked for signs? Well, it's either root 2 over 2 or negative root 2 over 2. So they wrote plus or minus root 2 over 2. Anytime you have a reference angle of 45 degrees. Cosines, same thing. It's always plus or minus root 2 over 2. Tangents, notice those were all plus or minus 1. All right, so cosecant is just the reciprocal of sine. So let's take root 2 over 2 and let's flip it. So then we got to rationalize, and I'll get 2 root 2 over 2. My 2's cancel, and I just get plus or minus root 2. How about secant? Same thing. Oh, but that's going to be the exact same thing here. So plus or minus root 2, and reciprocal for 1 is just 1. Okay? So use this chart to help you figure out when you've got a reference angle, you can go through and fill those in. All right, I'm going to go to part 2 of the video now.